It was 5,000 years into this playthrough that he finally lost his mind. He's standing on a spaceship behind the mainframe, looking at a knot of cables, trying to figure out the latest bug in the system. He gets this déjà vu feeling. There is something extremely primordial about all this. He started doing other stuff, drawing spaceships. He built this animation in Python. It shows all the rockets that fly between the outposts. In the Factorio mod, the planets and moons look different, but in real life it would look something like this, with distorted sizes, distances and velocities. Everything is distorted here. In reality you wouldn't be able to see anything at this scale but the sun. The sun would be about 1 pixel in diameter. Rockets fly between outposts on Mercury, Venus, the Moon, and this geostationary space station around Earth. And then there's Mars and some moons of Jupiter. This may look like a lot of rockets, but it's only because time is moving really fast. And from Earth, there is about 1 rocket launch every 2 days. The planets outside Jupiter have not been visited yet. You can see Saturn, Uranus and Neptune moving really slowly in the background. Chapter 1. Factorio Space Exploration is far into the future. Factorio SC does a pretty decent job of highlighting the scale and complexity that humanity will face when trying to build a system that looks something like this. Elon Musk and his apostles say it's gonna take 50 years. In-game, to go from something that looks like this, so rockets going regularly to and from the space station and the moon, to having something that looks like this, took me 4,000 years. Assuming the 1 hour in-game is 10 years in real life. So it took me 30 hours to go from steam power to the first outpost on the moon. IRL, that would translate to 300 years between 1750 and 2050. Assuming we have an outpost on the moon by 2050. As I was here, I thought that it would take me 30 more hours or so to expand to some more outposts, like to Mars or Venus IRL. No, in-game it took me 300 hours. 3,000 years. And now it's 2,000 years beyond that point, and not a whole lot has changed. Factorio SC has something to say about this idea that technology and industry will progress at the same rate as it does today, or faster once we're at this stage. Rather, the story is something like, once we have a permanent outpost in space, we enter a stagnation era. This is just speculation, of course. 5,000 years is a lot of years, and it's worth taking a step back to look at the many other simulators besides Factorio SC that take it somewhere completely different. Some are more serious than others. It's like a spectrum going from pure sci-fi to super realistic ones that only make predictions based on where we are in science right now. One of these super realists could write about rocket engines that are currently available, but meanwhile, some pure sci-fi nerd can write about engines that are doing faster than light travel. And just because sci-fi guy doesn't base his work on current science, doesn't mean that it's less meaningful. It would be like saying in archaeology that it's more important to excavate Neolithic sites rather than Paleolithic ones. There is this inevitable point in number of years away from us where everything gets fuzzy, but that doesn't make it any less meaningful to study. This depiction includes sci-fi elements, but most of what is shown here is grounded in current science to some extent. Humanity could build something like this, technically speaking. There's no specific material that we lack to do it. It's just not prioritized. 2. A future without humans. Going a bit deeper into what the defining features and quirks are with this particular Factorio simulation. The main obvious one is that everything is about building out this machine, robot factory and logistics network. It's as if we would describe our world to the Romans by only talking about factories, warehouses, how we do logistics and energy. Compared to popular sci-fi or cyberpunk, think Dune, Foundation, Star Wars, Expanse, they always have a lot of social and political, human societal themes. Factorio doesn't have any of that. It's a totally mechanistic, industrial view of the world, with some cockroaches sprinkled in. The reason we don't see this very often is because it isn't that exciting to us. We live in a humanity bubble. by design. We like human things. Factorio is an anti-human dystopian place. It's easy to get totally lost and miserable, but it does remove human bias, and that shouldn't be underestimated. If we go back to archaeology, we have learned a lot about our past based on very primitive finds, like burnt coal, providing evidence of the innovation of fire, or pieces of flint, or the pyramids of Giza. They say so much about civilization thousands of years ago. So we can think of this Factorio simulation as following the same materials track. We can think of the Factorio save file as a snapshot in the history of the pyramids, but it's about what things might look like in the future. Another approach is to think of it as a form of game of life type induction. Just as the rules in Game of Life, the rules in Factorio are simple and deterministic. In small scale, this game seems trivial, like placing a block of stone on another block of stone. This game is dead, right? After running for a while, when the level of complexity is through the roof, we can still say the game is dead, but it doesn't feel as dead. Game of Life is inductive in nature. You feed the inputs to the simulation and see where it goes. Compared to more deductive reasoning, the library astronomy bookshelf has these thick books by people like Michio Kaku that have a lot of theory about the future. These books are mostly not based on running simulations. They're not inductive. It's more like expert knowledge based on collected data from astronomy. They are good at certain things, like coming up with concepts like the space elevator or FTL. And simulations are good at other things, like working with the fact that technology development isn't linear. A lot of the time it feels like nothing is happening in this simulation. Then there is some breakthrough in technology that allows a bunch of new things to happen. And then it's back to 1,000 years of Dark Age. 3. Big space stations. What might a big space station look like in the future? This space station is about 1 kilometer long and in a geostationary orbit around Earth. What does geostationary mean? It means that it's located at an altitude where you never have to fire any rockets to keep the space station in orbit. That's 35,000 kilometers from the surface of the Earth. In real life, the ISS, International Space Station, is orbiting at 400 kilometers. It's called the low Earth orbit. It's kept there because it's cheaper to send rockets there, like these SpaceX and Soyuz rockets. And a bunch of other reasons. But for a space station this size, let's say it's millions of tons and it's a docking station for rockets and materials coming in from other planets, it's very probable that it will be in geostationary orbit. I'm comparing with the ISS IRL, but it doesn't make that much sense, because on this scale, the ISS is just a small science experiment. Like, the ISS is 109 meters, would be this size. And by the way, it's due to be decommissioned in the 2030s, without any plans for a replacement. Instead, the plans right now are about going to the Moon and Mars to run other small-scale science experiments. But why do we need a space station in the first place? Apart from being a docking station for incoming rockets, the Factorio premise is that the space station is going to be a factory, and is going to produce certain materials that can only be produced in space. That's just like IRL. We discovered that certain materials, like crystal structures, can only be produced in weightlessness. And the Factorio idea is that this then becomes a factory, and then further in the future, we will start demanding one of these materials at a massive scale down on Earth. Say that we come up with a way to produce a glass that is as strong as diamond, while being as cheap as normal glass. But it can only be produced in weightlessness. And say then that the Earth market will want millions of tons of this glass. So this massive glass factory starts growing in orbit. And eventually, a few hundred years later, for example, more such materials will be invented. And there will be this transition where these materials are kept in orbit because it turns out to be cheaper to move industry up into space than the materials down to Earth. We can think of a similarity to this in the archaeology retrospective again. You go to Manhattan in East Coast USA and look at their records. 400 years ago, it was just a colony exporting raw materials, whereas today it houses the New York Stock Exchange, that is, the global center of trade. This space station went through a similar process. Real long time ago, it was just like our ISS, but then it grew, went through a lot of stages. It's been 4,000 years now, and all the work on it has widened the perspective on some processes that we today might not think of as a big deal in our ISS world. But when some things get scaled up enough, they sneakily become this massive time sink. I'll talk about some examples soon. The only thing I read about geostationary orbit before in the literature is about the space elevator, but I didn't realize till this Factorio playthrough that space elevator is much further into the future. Space elevator is pure sci-fi. We couldn't do it with our current tech, and it would still have to be anchored on a geostationary space station. So I guess the point is that running the simulation teaches a lot about precedence of things. We don't know when things will happen, but we can get a better idea of the likely order in which things will happen. Another big space station is built much later, but still before the space elevator in this asteroid belt. It's the equivalent of the real asteroid belt between Mars and Jupiter. The IRL asteroid belt doesn't really look like this. It's made up of smaller rocks that are tens of thousands of kilometers apart. But it's still material, and if one manages to accumulate this material in a specific place, it could end up looking something like this. Who knows? 4. Why does it take so long? Diving deeper into some of the challenges that come with building this type of space industry, according to Factorio. One of them is resource balancing. This factory grinds down to a complete halt once and then. It's like a Great Depression every 10 hours or 100 years or so, because some material is lacking, or there is some choke going on somewhere, because material is piled up. It's surprisingly difficult to foresee how much of each material will be needed in different places in the solar system. Guess what the most common rocket cargo between Earth to the geostationary space station was the first 3,000 years of its existence? All these rockets going to the space station are completely filled with water, because water turns out to be the most important thing to have in space. It's used to produce various fluids and plasma that are used by various production facilities. It took a while to realize that this seemingly obvious water transportation from Earth was extremely expensive. Just as comparison, IRL, it costs $10,000 to send a bottle of water to the ISS. So one thing one then realizes is, if it isn't cheaper to send water from some smaller planet or moon to the space station than from Earth, because it's just cheaper. Another thing is waste management. After becoming this massive factory center, the space station slowly morphs into this scrapyard of stuff that was used a long time ago, and eventually became leftovers that needs to be dealt with. Here, for example, look at all this steel. I'm trying to get rid of it by building space station scaffolding, but there's simply too much of it, so it just lays there, disconnected. Here, I have this buildup of sand on the moon that I don't know what to do with. I mean, I could figure it out, but the list of things to figure out is long, and it's not like sorting out a pile of sand is going to have the highest priority. Unfortunately, sometimes when one has seen this type of thing one too many times, like the sand, one snaps and says, screw it, I'm gonna sort out this low priority sand issue now. Problem is, when one gives up like that, one risks causing a much bigger problem much later on. For example, one of the early things I did on the space station was to build it such that all the scrap was loaded into a rocket and sent down to Earth. Sounds reasonable, right? Things get sent up into orbit to produce stuff in space, and then the scrap gets sent down to Earth for recycling. Only to realize later that it doesn't make any sense at all. It's much more efficient to do all this scrap recycling on the space station. This is the scrap processing pipeline that I have right now. As you can see, all of this scrap is turned into materials that are all needed on the space station. At first, this quick fix of sending scrap down to Earth didn't seem like a big deal, but it ended up with massive amounts of rockets and jet fuel being wasted because I kept delaying implementing a better fix, since I'd already done the quick fix. This is an example of cascading failure, and they become more and more horrible as the playthrough progresses. One of the cascading failures I had was of the more violent and catastrophic kinds, when I went to Ganymede, one of Jupiter's moons. So I began to pack a first rocket. Since this is the first trip, I need to think about what to put in it. The previous first rocket to another of Jupiter's moons was military, because the landing zone there had special environmental hazards, let's say. Looking at Ganymede from orbit, it also has some of this hazard, but not very much. It says 7% here. So the first rocket that I packed to it was this standard base building one. It doesn't have any anti-hazard gear in it. So I launch and land successfully on Ganymede and spend the next 5 hours, so 50 years, building the outpost, with the idea that I would send an anti-hazard rocket after I had confirmed how big this hazard issue actually is. That was not a good decision. The problem with the hazard is that it can get very bad quickly, like a big meteor hitting Earth IRL. So even though everything feels great for 50 years, if a crisis hits and one doesn't have the right gear around, the whole outpost can just collapse. It's a cascading failure, and so that happened. I didn't know what to do for a while. There was no gear around for protection. I had to remote load a military rocket and send it over, and it takes a while to prepare all this. Felt like aliens for a while. It's similar to this lowering the guard thing one does sometimes when working on some big project. You get self-confident, start underestimating direct threats, and next thing you're in trouble. The usual cascading failure is just cognitively draining, though. One example was when I was building out the space station to reach the next spaceship building technology, and I realized I don't have enough of a certain material, beryl. So where do I get more beryl? There is beryl in the asteroid belt and water, which is huge. So screw it, I jump into a rocket and escape to the asteroid belt now. I don't want to think about this complex stuff I was dealing with before. I land on the asteroid belt, build an outpost and start looking at producing this beryl, only to realize that I also need sulfur to be able to do it. Okay, so where is sulfur? The best option is to go to Io, one of Jupiter's moons. So I take a rocket to Io, build an outpost and some sulfur infrastructure, and set up a cargo rocket to ship sulfur back to the asteroid belt. After that, I go back to the geostationary space station, because it feels like the right thing to do at this point, to do some housekeeping and think about if anything else is needed at the asteroid belt outpost. Turns out I need plastic, and pyroflux, and cryonite. And I realized that sorting out each of these materials requires visits to 3 separate outposts, and for pyroflux, even building a new outpost at Mercury, since I haven't been there before. But I don't want to go there. Long-term, pyroflux is needed everywhere, and I don't want to send it with these deprecated rockets I'm using, but instead want to do it with these later spaceships, because it's more efficient. But that is what I was trying to research in the first place. No, in fact I need to go back to Io, because it also has enough beryl that I can send it to the space station and finish the spaceship tech. The original plan was that I wanted to go to the astrobelt to escape complexity for a while. And now I need to go to Io to set up a shitty temporary operation, because that turns out to be the best thing to do in the long term to avoid a looming cascading failure. It's so anticlimactic. All these kilojoules of brain power spent with no reward. Heidegger spaceships. We're back at the time that I quit. This was about 2 months ago. But it could have been 2 minutes ago, or 2,000 years. Time is relative. The reason for Heidegger was this controversial German philosopher, is because he encapsulates what it means to be this larval little human thrown into the universe. The size of space is humbling. We're all flying around on our personal spaceships out there, and it's easy to feel lost sometimes. You just have to cope somehow. Zen people call it surrendering or something of the like. Napoleon called it being useless. He referred to monks living in the Alps, instead of participating in his supposedly useful plan, conquering the world through mass killings and warfare.